Hi and welcome to this new lesson. You should be now familiar with the basics of the neuron. So you should know what is the feed forward, what are the weights, what is the back propagation and the activation function. Now we're going to expand a bit the concept of the neuron by dividing it into layers. And this is really important, especially when we want to connect more neurons, that we have a clear idea of what the layers are. So we will see visually first what are the layers, and then we will create on the code a layer class. Let's start. Let's take a look at the neuron. We have here 9 inputs. So here input. Then the blue one, the weights. Then we have the activation function right here. And the output. Here we can now draw a layer just right here. I'm going to make a bounding box. This way. Now let's take a look at what enters in this box, or we can say layer, and what goes out from this layer. Here we can see that this layer is connected with the input. On the input we have 9 pixels, so for each pixel we have a weight. So the entrance is 9, and then we have here, you see, just one output. So in this output we're going to tell if the image is a vertical line or a horizontal line. So let's call this one just output layer, which is the final layer. In this case we have just one neuron, so the final layer is always the output layer. Now, before proceeding with any explanation about this, let's jump right away into the code to create a layer class which represents this neuron. We're now going to start with this empty file where we just have the sigmoid and sigmoid derivative, and we're going to build again from scratch the neuron, but this time with a class. So we will create a class called layer to make on the code what we represented before visually. So class is equals to layer, and then we initialize the class def init, and of course you need to be familiar with object-oriented programming, or at least understand the basic of this to be able to move forward and to have everything clear what we are doing right now. Def init, so now we are going to create the weight equals to np. Okay, before we were doing np array, and we will just put 9 numbers because our input was of 9 pixels, so we put it 0.5, 0.5 and so on. Now we're going to do this a bit better. So instead of just putting the numbers, we're going to use a numpy function which to generate the numbers randomly. So we will say np.random.rand, and now we need to define the size. The size is 9 numbers in just one row. And we need to call self right here. So everything that we will put with self, we can call it later on the other functions inside the same class. And this, if you're not so familiar with object-oriented programming, it will be slowly easier to understand when we're going to create the object. Let's now print initializing layer, and now we're going to create the layer. So we say output layer is equal to layer, and if we run this code, we see initializing layer. So each time we create an object, this function runs by default. So we can also print the weights, print weights, and then print self.weights, and let's run this again. Okay, these are our weights. So we have 9 numbers from 0 to 1, and each time we run them they are different. So it doesn't really matter, we want always to have random numbers because that's what weights are, and then of course the value will change when we train the neuron. Now, to make things more easier to understand, let's do one small change. You see here we have np_random.rand91. Let's now take a look at our neuron visually. So you see output layer, and here we have output layer, and here we have on the layer we see that we have 9 inputs, so 9 numbers, so we have 9 weights for the output layer and just 1 output, so 9 are entering and just 1 is going out. And here you see for the weights 9 and 1, 9 entering, 1 going out. So we can say init input size and output size, and also we can copy and paste this when generating the weights, input size and output size. So when we create the layer output layer object, we say layer. What is the input size? The input size in this case is 9 because our image has 9 pixels, and of course if we use an image with different pixels than 9, so of course we can easily change this by changing this number. And 1 output size. So if we run this, we see these are our weights. So if we have a smaller image, let's say just 4 pixels, so the input will be 4 and the output still 1. So you can see how easily we can change the size of the layer. Now let's move on. So after we initialize the layer, of course, we want to create the rest of the neuron. So the neuron has the other operations. Let's start with the feed forward operation. So we define the function def feed forward. So the feed forward operation gives us a weighted sum. So np dot, we multiply the input with self dot weights, and of course we want to take the input when we do the feed forward. And what is our input? Our input is the dataset, so in this case are the images. I don't have any images on this file. I'm going to take the 2 images, the vertical and horizontal line from the previous file, from the previous lesson. So let me take that one. So this is the file from the previous lesson. We only need the input. So from input to labels, that's all that we need. And now I go back to the current file. Let me place this just at the beginning of the file right now. Let's make sure that we are importing all the libraries, so NumPy and CV2. We have vertical image and horizontal image. And so we have the images inside the dataset. We have image flatten and image flatten too. So we have the dataset when it's already pre-processed, and then we have the labels. And let me take this one below. So I copy this, and we're going to paste this before the output layer. So we have input, we have the dataset, labels, and we can print this so that we can make sure that everything is correct. Print input, we print dataset, and then labels, let's leave it for the moment just right here, and let's run this. So we see input, we have two images, so we have an array, and then we have first row, first image, second row, second image. And the images are the same one I used before, so this is the vertical line and the horizontal line. And then we have the random weights of our output layer. So input and output layer. So I'm putting in this way so that visually it's really easy to understand. So if we take a look at the image, we see input, and then the input goes to the output layer. So input 9 numbers. The output layer takes 9 numbers and gives 1 in return. So here we see we have the dataset, which is the input, and then the output layer, which takes 9 numbers and gives 1 in return. And now we train this layer. So train. So first of all, we do the feed forward operation. Output layer dot feed forward, and the output layer now during the feed forward is taking the input. So we give now the images, the dataset, and in return, when we do the feed forward operation, we take an input, and in return we get an output. So here is the input. Let me complete this function right now. Weighted sum, and then we have the output is equal to the sigmoid of the weighted sum, and return output. And output is equal to output layer dot feed forward dataset. Now let's print the output, and then print output, and let's run this one. Okay, you see input weights after we initialize the layer weights, and then the feed forward, it takes the input and it gives us the output. This is the result after the first image. So it is telling this is the value for the first image, which is the vertical line, and this is the value for the second image. Of course, these values are wrong because the neuron hasn't been trained yet. So now we go further, creating the next function, which is the backpropagation. Def backpropagation. And the process of the backpropagation starts by calculating the error. So how much is the detection wrong? So the error, it is equal to the output minus the labels. So in order to get output and label inside the function, we need here to call them. So we have output, then labels. Then why do we need the error? we need the error to know how much we need to adjust the weight. So we use the error to calculate the adjustment. And the adjustment is equal to the error multiplied with the sigmoid derivative of what? Of the output. And now finally we're ready to get the weights update. Weights update, it is equal to np dot, so it's the weighted sum of what? Of the input. So we need to take the input. Let's take here input with the adjustment. And just remember here to use input.t, so transpose. And we will see, I explained that difference in the previous lesson. So if you don't put this, you will get for sure an error. And now, one last step. First of all, let's print weight updates. Print weights update. Print weights update. And we just need now to call the backpropagation. So output layer, we do the feed forward operation. So we take the dataset, which is the input, and in return we get the output. Now we need to make the inverse procedure. So we take the output and going backwards, we will adjust the weights. And we just need to call the function output layer dot backpropagation, and backpropagation takes three values: the input, output, and labels. So we say input is our data set, then output is exactly this one, and then labels. And so I can run this to make sure that everything is correct. And here we see the weights update. So this is, we see one column and second column. This happens because now on the dataset we have two images. So this is the weights update for the first image, and this is the weight update for the second image. So first we have the vertical line, and then we have the horizontal line. And the only thing that we have to do finally is to update the weight, so to subtract this from the original weights. And we can do that by simply say self.weights. So the weights that we generated at the beginning, we're going to change them in real time, minus or equal to the weights update. And let's try this once. Okay, trying this, we see an error. Let's focus on this error. We see line 54. So when we call the backpropagation, so we know that the error is inside backpropagation function, and then specifically is saying line 39. So if we take a look at the line 39, is the self weights minus weights update. And when we see such error, I know now exactly what is the error, but I want to show how we can dig deeper to understand what's the error. So that's the best way to understand everything. So we're trying to subtract self weights with weights update, and we get the error because it is telling that the shape is different, which makes really no sense if we don't see it. So the easiest way is to print both of them. So we print weights update, print cell weights update, and then print weights and print self.weights. And of course, we have to print this before the error, otherwise everything after the error is not executed. So we will print this before the line which gives us the error, and we can run this. So we see weights update and weights. Let's take a look at our neuron. This is our neuron, and we see that the neuron has 9 inputs and 1 output. So here we have 9 weights because 9 are the inputs, but then the weights update doesn't correspond to this. And now it happened that we have this weight update because we have 2 labels, but we want them to process them in a different way, because if we had more labels, then we will have more weights, but the weights are always the same. If we have 9 weights at the beginning, they will be always 9. We just change the value of the weights. And this happens exactly because the way we gave the label. So if you see, we are giving the data set, we have the image 1 and image 2. So let me print, okay, I have already data set printed, so let's also print labels and print labels, and let's run this one. So we have input, it's an array, and then we have first row image 1, second row image 2. While for the label we have just an array where we have first value corresponds to this and second value corresponds to this. We have to give the input and the labels the same shape, so in order to not to get this error. So labels, we could do this in 2 ways. Either we do this manually, so this way. So we create an array, and then we have first element and second element, and I can run this. You see that now we don't get the error anymore. But also another approach to get the exact same shape will be to have 0 and 1. Keep in mind, array and then array inside again, 0, 1 dot t. It's just a different way to put things in the same order. You see labels 0 and 1. And so that's how now we see the weights and then weights update. And so our neuron is now ready. So the same thing that we did in the previous lesson for the training, we have to do right now. Just put everything that we have here in a loop. And first of all, I want to remove this printing, which needed just to find the error. And then on the training, we say for I in range, let's say 100. And we put here everything in the loop. And now we can run this. Input labels, these are the starting layers at the beginning, the weights at the beginning, and then the final output. The final output is telling us our first image is supposed to be a vertical line, so it is really close to 0, and the second image is supposed to be a horizontal line. So it doesn't matter how the weights begin, they will reach a way to classify correctly both images. And the weights will not get always the same, because if we start weights differently, then after 100 iterations you will get different weights, but the result pretty much is going to be correct and almost the same. So just out of curiosity, we can print also the final weights after 100 iterations. Print final weights and print now. We can easily get the weights of the layer just calling from the object output layer dot weights. And this is why it's so useful to have everything in a class, like just to call the weights, just one line, easy as that. And now we can run the neuron. And this is the result, correct even now. So these are our weights at the beginning, and these are our final weights. 0.67 minus 1.40, 0.10. Let's rerun the class and let's see how do we get them. Final weights 0.24. You see that each time we get different weights because the neuron trains in some different way. It depends on how it starts, but finally the output is always the same and correct output. Now you see all this with just one neuron. We will see in the next lesson how to add more neurons and more layers, and why, especially why that's necessary after a certain point. See you in the next lesson.